multi-mass means it is having the, it is not a one turbine unit, it is having the, like this, it may have the high pressure turbine, this is one combination, high pressure turbine, then it is intermediate pressure turbine, then it is a low pressure turbine, then low pressure B turbine, then generator, and then it is exciter. So this type of model means, and they are connected through a shaft. Here you can consider it is a shaft, like this. You can say it is, it is like this. Here, this is one unit, high pressure. It is generator. It is exciter. It is a intermediate pressure, low pressure, and there is a shaft. So such type of representation of the turbine may be there. Then, if such type of representation, which is the true, in fact, our turbine is not a very small unit, it is a very big unit. It may, our whole generating system is a very big unit, and it may consist of, it may be as long as of 50-meter length. 50-meter length, you can consider, you can think what is the length of the whole generating station. And it may have the several hundred tons of weight. Weight of the turbine and generating system may have the, say, lakhs of kgs. So this system, mechanical system, is not, it is not appropriate to have, to consider it as one unit. And further, the turbine consists of disc, blades. This here, it may have the disc which is rotating, then it may have the blades just to cool it, cool the each part, and the whole mechanical system. Then this can be, they are connected, high pressure, intermediate pressure, low pressure, they are connected through a shaft. And the shaft is represented by, it is, shaft is, can be represented as a, it may have the twist. While rotating from here to here, shaft may have the twist. So this is considered as a, and if some oscillations are there, it may damp out after some time. So this shaft is considered as a massless. If the mass of shaft is not there, but mass of the, you can consider this unit is connected with this unit with a this shaft, which shaft is represented by a spring constant K, and damping this means spring is massless. If they are rotating at a different power angle, or some different of speed is there between the two, then there will be twist in this. Either it may be soft, but it is considered as a massless, so it is represented by a spring constant K, and the damping by represented by a damping. So this damping, the role of damping is to damp out the oscillations between the two. So in this way, the whole mechanical system is represented in this way. Now, just to analyze this, just to analyze, as we have did the modeling while describing the AGC, we did the modeling of turbine, we did the modeling of speed governor, we did the modeling of generating system, then the excitation. So we did the modeling, but here just to understand there is a difference between the AGC and here. Here we have to describe, we have to analyze the different oscillations. Means oscillations, as I described, what is the inter area oscillation, what is the inter plant oscillation, what is the intra plant oscillations. So these oscillations we describe, means in the inter plant itself, this may oscillate against this may oscillate against this, the whole mechanical, whole turbine system may oscillate against the generator, and the whole this power plant may oscillate against the electrical system. In this way, there are various types of oscillation. If we want to understand those oscillations, then we have to model each component separately. Okay. Now, just to understand that, suppose here, if here, say there is a if we so anyway, if we consider a spring here, say suppose there is a spring here, like this, there is a spring and the weight is connected here, then this system, one spring along with this weight can be represented by this equation, m d square x by dt square d dx by dt kx is equal to f. Is this equation known to you? ये पहले आपने पढ़ी हुई है कभी? हेलो।
यस सर, पड़ी हुई है सर, कंट्रोल
ये
सिस्टम।
हाँ, ये क्या क्या बताता है? इफ यू अप्लाई द फोर्स में
मैकेनिकल सिस्टम।
mg, suppose some weight is connected through mg, and this equation means this will describe the oscillation. If the damping is not there, if you apply the force, or even if the acceleration, or in the steady state the f is equal to kx. F is equal to kx means if f is equal to say 5 kg of weight is connected, then 5 into g is equal to kx, and according to spring constant there will be displacement of x. मतलब जितना weight होगा उतना वो spring आपका खिंच जाएगा. But before coming to the steady state, it will oscillate like this, and this oscillation will be represented by this equation. And if damping is there, it will damp out after some time, and finally steady state condition will come. But we are interested in these oscillations. So this whole and oscillations and how much time it will take to damp out. That's why this is the net equation which we have to analyze for a spring mass system. Similarly, if rotational, if this is say this is a spring and here a some weight is connected and the twist is given. Here a linear motion is given. If you give the twist in this, that torque, if you apply the torque in the spring, then this will oscillate. This will oscillate around around the around the shaft itself, around the spring itself. Then the equation will be represented by this: m d square delta by dt, d square delta dt square, d delta by dt, k delta plus t. Is this okay?
यस सर।
Okay. So this equation is also known to you in case of a rotational motion. This equation is there. In case of a linear motion, this equation is there. This equation can be further written as a md equal d delta by dt is equal to d omega by dt. D delta by dt is equal to omega. So it is a m d omega by dt. Here is a d omega, k delta and t. Okay. So now now since in the elliptical system, if the torque disturbance comes, means if the disturbance comes, because we have to study the different oscillation, and different oscillation are produced because of the change in the steady state. The t is equal to k delta, but we are not interested in t is equal to k delta. But as soon as the load changes or whatever change comes, then because of the change in torque, the whole system oscillate, and that the effect of disturbances of we have to analyze. So making the derivative of this m derivative of this means m d delta of del omega d by del omega k delta delta t. So this is the equation. Now if this equation is applied here, if you apply this equation here, means let us have this one unit, third, three. This is oscillating. If some disturbance come, because disturbance may be either the electrical torque changes, electrical. Here, what is actually the working of this? It gives some mechanical power, is some fuel entry is giving to this, and because of this mechanical torque, high pressure is produced here. Because of this, another intermediate pressure here, mechanical torque is given input. So here some pressure will be developed, here some pressure will be developed. Rather, the fuel of one is used in the another, and fuel of that is used in the another turbine part, then another turbine part. So everywhere there will be input, torque will be entered into this. This torque will be through the shaft. Through the shaft, this torque will be transferred to the generator. And from the generator, we take the electrical power T. Here there is input mechanical power, and in terms of fuel, in terms of the mechanical torque. Here there is electrical power. So this is in the direction upward direction. Means T is out. Here it is input. Here it is out. And this is the excitation role of this to control the reactive power. So it does not have any torque. Neither it is giving the torque, neither it is getting the torque. So this is generator through the stator. It is giving the electrical power output. So there is equivalent electrical torque. This is represented by Te. So now let us have, because of this Tm1, Tm2, each will have the different torque. So there will be relative motion, relative oscillation in between the two. Let us write the equation for this. And equation for this, if you write according to the same, means this will be the oscillations of this will be affected by this and by its own. मतलब आपने जब when you have given the TM mechanical power, it will try to oscillate with this torque only. This torque means TM3 is equal to m d square delta 3 if the angle of this is delta 1, delta 2, delta 3, delta 4, delta 5 like this. So say angle, or sorry, this is 1 TM1, so delta 1, delta 2, delta 3, delta 4, delta 5 like this. So this angle, so it will be m d square delta 3 by dt square plus m plus d delta 3 by dt plus k delta 3 is equal to force applied. So TM3 applied, but the speed of this is not independent. If it is independent, is not connected with the shaft, then this equation is okay. But since it is connected on this side with this high intermediate pressure turbine and this side with the low pressure turbine, because of the this is rotating with the speed of omega 3, this is rotating with the speed of omega 2. Although they are almost same, but because of this, and this is omega 3, this is omega 2, so there will be some, because of this shaft twist, there will be effect of this on this and effect of this on this. Means omega 3 is not independent. It depends upon this omega 2 and omega 4. So this equation, now you see, you remember this figure from here to here, then this equation can be written like this. You see here, if you see here, d delta d omega by dt, this is like m d omega by dt. So it is m3 d by dt omega 3 minus omega 0. Del omega means omega 3 and omega 0 to power frequency. With respect to power frequency, this here. And damping because of the omega, because of the and this now because of the omega 3 there will be damping. If you see again here, this figure, sorry, this figure, this is causing its own damping. If nothing is there, then because of its own damping, it will damp out after some time. And if it is not there, because of this also, because of the difference between the two, there will be damping in the also, because of the difference between the two, there will be damping because of this. मतलब जहाँ भी एक दूसरे को, सपोज करिए दो लोग हैं, एक दूसरे को पकड़ कर चल रहे हैं, तो एक की स्पीड कम होगी, then it will cause the damping in the other. एक की स्पीड फास्ट होगी तो वो दूसरे को डैम्प करे, मतलब उसकी स्पीड को फास्ट करेगा. अगर आप दो लोग हाथ पकड़ के साथ साथ चल रहे हैं, तो अगर एक की स्पीड कम होगी तो दूसरे की भी स्पीड ही कम करेगा. एक स्पीड ज्यादा होगी तो दूसरे की स्पीड एक दूसरे को इन्फ्लुएंस करेंगे इन द स्पीड as well as in the d. D means displacement also. That's why this equation can be written as its own. देखिए इसकी डैम्पिंग सभी की वजह से D33 अपनी ओन की वजह से D32 and D34. एक तरफ 32 एक तरफ 34 है. This is 34 and this. Okay. Now इसकी वजह से तो डैम्प आउट होगा because of all side. Shaft on one side, shaft on another side, it will be damp out. Now, and it was the third unit, and because of the second and fourth unit, unit also rotating with the omega 2, so it will help not to damp. So this is D32 omega 2 minus omega 0. Again देखिए ये तो इसको अपना डैम्प करेगा, लेकिन ये ओमेगा 2 ओमेगा 4 वो अपनी स्पीड से रन कर रहे हैं, तो उसको डैम्प आउट को रिड्यूस करेंगे. देन दिस इज के डेल्टा, here like this, k del delta. So K23 on one side and K34 on another side. So K3 माने जितना पावर एंगल में डिफरेंस, जितना ट्विस्ट होगा उसके अकॉर्डिंगली इसका स्प्रिंग शाफ्ट कांस्टेंट K23, इसमें ये ट्विस्ट है डेल्टा 3 माइनस डेल्टा 2, और ये स्प्रिंग कांस्टेंट है. सो इट इज ए KX, और दूसरी साइड में डेल्टा 3 डेल्टा 4, और ये इसका स्प्रिंग कांस्टेंट है. तो डेल TM3 मैकेनिकल पावर थर्ड यूनिट में जितना होगा उसकी वजह से ये इक्वेशन बन जाएगी. आई थिंक दिस माइट बी क्लियर टू यू. ओके, नाउ दिस इक्वेशन कैन बी रिटन हियर. यू सी d omega 3 minus omega 0 can be written as del omega 3, and d by dt is equal to dot. D by dt is the dot, and here you see then this is on this side and rest everything on the right hand side. If you take this everything on right hand side, then this minus will be positive on that side. So d32 omega 2 minus omega 0, and d34 omega 4 minus omega 0, and this will be negative. This will be negative, and finally, and next इसके आगे K23, this is same. Make the bracket close here, and this is the same equation. Same, this Tm3 and M3, everything is divided with the M3. So that's why here everything is divided with the M3. So this is the equation for omega 3, del omega 3. Matlab, the angular velocity of the third unit, that was the low pressure turbine. This that will be given by this equation. Similarly, we can write the equation for 2. On 3, on one side there is a 2, another side there is a 4. So we can write the equation 2, where unit number 2 there is high pressure turbine here, then there is a low pressure A turbine here. Similarly, for this, the unit number 3 is here, unit number 4 is here. जैसे इसकी इक्वेशन लिखा है थर्ड की, वैसे ही हमने सेकंड और फोर्थ की इक्वेशन लिख लेंगे. ओनली क्या है, या तो फिगर से लिख सकते हैं, या 3 की जगह 2 लिखते, 2 की जगह 1 लिखते, तो इक्वेशन आ जाएगा एवरीवेयर. ऐसे ही इसमें 2 की जगह 3 और 3 की जगह 4 लिख देंगे तो इक्वेशन आ जाएगा. सिमिलरली फर्स्ट यूनिट के लिए इक्वेशन ये लिखेंगे, 2 की जगह 1, 1 की जगह 0, तो ये टर्म नहीं आएगा. ऐसे ही इसमें ये टर्म नहीं आएगा, सॉरी इसमें एक टर्म नहीं आएगा. इफ दिस इज नॉट दिस, ये टर्म आ जाएगा. तो इस तरह आपने ये वन इक्वेशन 1 2 3 4 5, all these equations can be written. 1 2 3 4 5 6. This is, now you see here again the things to remember is, here it is a Tm1 del Tm2, mechanical power of unit 2, mechanical power in unit 3, mechanical power of unit 4, and mechanical power is not there in the unit 5, that it is a generator. Here it is a high, this is the equation for high pressure turbine, then intermediate pressure turbine, then low pressure turbine, then low pressure B turbine, and then this is the equation for generator. In case of a generator, electrical power is not input, electrical power is taken. So in place of plus Tm, it's Te, electrical power. And mass of the generator is M4, mass of the these turbine are M1, M2, M3, M4. Okay. Now, this is the equation for exciter. Now, so these are the 6 equations. I hope you can write these 6 equations. ठीक है, लिख सकते हैं? हेलो?
Yes, sir.
तो जैसे एक इक्वेशन लिखा है थर्ड, उसी तरह आप or you write all 6 equations. In addition to this, the some more equations are there. This is the del I is equal to d omega by dt. मतलब हर एक के लिए एक इक्वेशन लिख सकते हैं. del 1 is equal to d omega 1 by dt, del 2 is equal to d omega, omega is equal to delta by dt, omega 1 is equal to delta by dt, omega 2 is equal to delta 2 by dt, omega 3 del delta 3 by dt. मतलब ओमेगा और डेल्टा के बीच का रिलेशन है. और यू कैन से I is equal to 1 to 6 मींस जो हमारे छह कंपोनेंट हैं, इसके 6 यूनिट हैं, हाई प्रेशर, इंटरमीडिएट प्रेशर, लो प्रेशर, देन जनरेटर, देन एक्साइटर. जो 6 हैं, हर एक का अपना अपना कुछ मास है, उसमें हर एक का कुछ पावर एंगल है और हर एक की ये एंगुलर स्पीड है. तो द 6 इक्वेशन कैन बी रिटन हियर, ओमेगा इज इक्वल टू डी डेल्टा बाय dt. एंड सिंस वी आर स्टडीइंग द change in frequency, that's why here we can write del omega I and del delta I. This is the dot means d by dt. So these are the 6 equations. These are the 6 equations and these are the 6 equations. In place of I, you can write 1 2 3 4 5 6. So then these 6 equations will come. So these 6 equations now, in addition to this, this is the electrical power. Here, this is the mechanical power, this is electrical power. Electrical torque. Electrical torque, we can write the equation for electrical torque in terms of the currents and currents now. ID, IQ. Torque, you know, torque is, ID is a current, one type of current. ID is the stator current referred on the direct axis. We will again describe, while describing the generator model, we will describe this, where I will just tell you ID is equal to this small I capital D. This is the electrical, this is the direct axis component of the current. Direct axis means stator, referred on the stator side. जो हमारा आपको बताऊंगा जो जनरेटर है, जनरेटर में तो स्टेटर flux of reference है, rotor frame of reference है. So all the ABC current, all the phase current of the stator, if you refer on the stator frame of reference into the DQ axis, in the DQ axis, D and Q are the rotatory frame of reference and ABC are the three phases. So stator side rotatory frame of reference, the current is represented by ID and this IQ, and this is the ID and IQ is the maximum short circuit current flowing into the stator when. So this is the dependent current source current referred on the stator side rotatory frame of reference ID and IQ. So there are two different current. We will later describe it that how the generator is represented by the two rotatory frame of references, because in detail study when we will do the detail analysis, we have to be because in case of a three-phase system, since all the phases are same, so we do all the analysis on per phase basis. सभी phases, phase A, B, C सब same होते हैं, इसलिए सभी analysis हम per phase basis पे करते हैं. And all phases are same, so we do only thing is the only phase difference is there. But here, since we are going to study the unbalanced system also, every time we are going to study the difference, so we have to make the convert the ABC frame of reference to the DQ frame of reference. वो next lecture में आपको detail बताऊंगा. But still, when there are two currents, two different current or two current from different two sources, then the torque is given by ID, means D component D axis में है, Q axis में. Otherwise torque is given by I, suppose ID, or if some current IA, IB and angle between them. No, torque is equal to IA, IB and sine of angle between them. Since they are 90 degree to each other, D and Q, so this will be the sine 90 is equal to 1, and this will be the equation for torque. This equation will be described in detail later also. And so change in electrical torque, if you differentiate this, you will get del T FD dot I. इसका differentiation करेंगे तो देखो एक बार इसकी वैल्यू constant IQ0, take it as a constant IQ0, derivative of this, then इसकी वैल्यू constant, then derivative of this, okay, derivative of this. Similarly इसमें एक बार इसका differentiation, and then it is constant, then derivative of this, then this is constant. So this is the del TE. So this del TE is equal to XD dot. To write this into the matrix form, if you write this into the matrix form, this constant value IQ, this IQ or ID0 means ID0, ये दोनों. So this can be written in this form, del ID IQ, and this means एक बार देखिए ये वाला आपका है ID IQ, del capital, this capital ID IQ take the two terms simultaneously, then later take these two terms simultaneously, and you can write into the matrix form like this. ये TE का equation है in the matrix form. Now anyway, now we know, now we have these equations, means we can write TE here. जो अभी अपने किया है, T की जगह ये लिखेंगे. You write T की जगह ये लिख लेंगे ID and IQ के terms में. Change in del TE means here you write into ID and IQ. So current flowing into the stator side, you know here. Then and these are the omega 1, omega 2 are the angular speed. These are the angle of each mechanical system. Now, and if these 12 equations, now we have the 12 equations. If you write these 12 equations into the matrix form, this is very blurred. it is not clear, but anyway, if you write the 12 equation, you know this is del, here it is del delta 1, here it is dot. Dot means derivative of del delta 1, derivative of del delta 2, derivative of del delta 3, derivative. These are the 6 equations. 1, 2, 3, 4, 5, 6. We have been told delta 1, delta 2, delta 3, delta 4, delta 5, delta 6. 6 equation. And omega 1, omega 2, omega 3. Del, derivative of del omega 1, derivative of del omega 2, derivative of del omega. These are the next 6 equations. So these 6 equations, if you write into the matrix form, such type of matrix will come. Here means you see, you check this del delta 1, all are 0, then this 1 will be multiplied del omega, this del omega 1. So d delta 1 t is equal to d delta 1, derivative of delta 1 t is equal to omega 1. एक equation ऐसे ही 1, 2, 3 सारी equation, 6 equation will come from here and next 6 equation will come from here. ये अभी clear नहीं है, but if you go through the book you can find this is very clear. बुक में आप देखोगे ये आपको स्पष्ट दिखाई देगा. आई थिंक इफ आई ओपन I think this is somewhat clear. This.
Yes, yes.
This, but in the book, because it is a very big size matrix, it is a size of this is the 12 by 12 matrix. So these are the small terms. ये बहुत छोटा छोटा दिख रहा है. So you can refer to the book here. ये हमारा, you can write it into the matrix form. So this is called as a system states, delta 1, delta 2, del delta 1, del delta 2, del delta 3, and omega 1, omega 2. They are the system states. So this may be called as a x dot is equal to a. This is a system matrix a x plus bu. X dot is equal to ax plus it is a b. This is a u input. So if you change the id and iq, मतलब अगर स्टेटर साइड में id and iq शॉर्ट सर्किट करंट्स अगर चेंज होंगी, मींस डिपेंडेंट करंट्स डी एंड क्यू, एबीसी चेंज होगा तो डी क्यू भी चेंज होगा. तो ये अगर करंट में चेंज होगा तो हमारे इस पे क्या इफेक्ट पड़ेगा, डेल्टा डी पे क्या पड़ेगा. तो वी कैन सॉल्व इट फॉर, as we know now, this can be in the short, it can be written like this: x dot is equal to ax plus bu. If the more inputs are there, then like this. Means actually this is not complete. I think this is not complete. Here it is a v1 u1 plus v2 u2. जैसे देखिए यहाँ क्या होगा, इस तरह का होगा. ये u1 है, ये u2 है. So v1 यहाँ से u1 u2 वो term will come here. इसको again there is some mistake in this. So this will be equation, actual equation will be x dot is equal to ax plus v1 u1 plus v2 u2. ये mechanical system हो गया, where x is equal to this. Since it is mechanical, so we have written as a m. It is a x, and this is system matrix. This, you know, this is a zero matrix. This is a one identity matrix, and it is a AKAT some another matrix, depending upon the system parameter. So इसको if we solve this, अब इसको solve करने के लिए now, as I told, the mechanical system and electrical system get resonance to each other. Electrical side में कुछ problem होगी, मतलब ID and IQ. If there is a some change in the currents, electrical power, if the current will change, then it will have the effect on this. So what type of oscillations are present? If we want to study those further in detail, similar to this, जैसे हमने ये mechanical system बनाया है, इसी तरह अब ये मैकेनिकल सिस्टम है whole where we have written the equation for the rotor of the generator but not on the stator side. Stator side की equation अभी नहीं लिखा है, so we have to write the equation for the generator also. जैसे इस तरह की equation लिखा है हमने, उसी तरह equation for the generator, ये मैकेनिकल सिस्टम हो गया. Then we will develop the system for the generator, then we will develop the model for the transmission side, and the overall modeling so developed since each subsystem is connected with another system. जैसे टर्बाइन हमारा शाफ्ट के थ्रू किससे कनेक्टेड है, रोटर से. रोटर मैग्नेटिक कपलिंग के थ्रू किससे कनेक्टेड है, स्टेटर साइड से. और स्टेटर इलेक्ट्रिकली किससे कनेक्टेड है, ट्रांसमिशन साइड से. और ट्रांसमिशन साइड पे हमारे डिफरेंट डिवाइसेस भी कनेक्ट हो सकते हैं, से शंट कंपनसेशन, शंट कैपेसिटर, सीरीज कैपेसिटर में भी कनेक्टेड. सो because of everything there can be a different modes of oscillations. जो मैं आपसे बात कर रहा था इंट्रा प्लांट oscillation. So those type of oscillations means हर एक कंपोनेंट में oscillate with each other. एक टरबाइन का एक हाई इंटरमीडिएट प्रेशर टरबाइन में इंटरेक्ट विद द हाई प्रेशर टरबाइन में इंटरेक्ट विद अनदर टरबाइन. इलेक्ट्रिकल साइड में भी ऑसिलेट. सो देयर आर डिपेंडिंग अपॉन जितने भी हमारा सिस्टम में, इस केस में 12 है तो 12 टाइप ऑफ ऑसिलेशंस आर प्रेजेंट हियर. एंड जब हमारा सिस्टम सभी कंसीडर कर लेंगे, इलेक्ट्रिकल, मैकेनिकल, स्टेटर, ट्रांसमिशन, देन द साइज ऑफ मैट्रिक्स after connecting to each other, size of the matrix is very big, and the different type of oscillations possible can be studied through the MATLAB or other suitable means. Okay, so this is about the mechanical model of the mechanical system. Similar to that, we have the different other systems. So we will describe those systems in the next class. इसमें कुछ पूछना है तो पूछें. I think it is simple. While we will go for the generator model, it will be little bit difficult. वो आपको उसमें 3-4 लेक्चर लगेंगे, वो बहुत डिफिकल्ट होगा. तो ये तो सिंपलेस्ट पॉसिबल है. That's why we have taken this as a first. Okay, because we have to convert with the help of the part transformation. We have to convert ABCX into the DQ frame of reference. Then it will seem somewhat difficult. So I hope